us to look at this chapter now that I've finished working on the handout. And basically, this is a structure that I've taken for this handout that I had promised you for long. So we have the introduction. Like I've been able to mix in, we have question 1. Question 1, December 2022. All right. We have stages of the life cycle. We have big data. We have the 5 V's of big data, types of data analysis, descriptive analytics, prescriptive analytics, predictive analytics. Tools for data analysis. If you look at your syllabus, we have tools for data analytics. Data cleaning tools, we have those ones. Okay, we have data management storage and data base administration, SQL, Oracle, cloud computing, AWS, etc. Reporting, visualization, Excel, Power BI, the famous W, MicroStrategy, others. We have the famous, again, data visualization. It was big in your exam. Benefits of data visualization. Types of visualizations, comparison, composition, relationships. So we have some question there. Qualities of good data. So practice questions. So this is what we have done, and really would want to even do it much better to make this class what year amazing. So December solutions, etc. like that. Remember your theory carries how many marks? 40 marks. 40 marks. 40 marks. So we have looked for questions from last sitting and from the pilot paper that belong to this particular topic, and they've been able to provide solutions for the same. Now, for this chapter, where would you suggest we begin? Because there are only 16 pages, I suggest that I go through this concept from the beginning pretty fast. What do you think? What do you think? The notes, you shall get the notes, yes. Nobody has gotten the notes yet. Nobody have been working on them. I've been working on these notes seriously, right? Because we can't really be teaching a subject where we don't have notes. All right. So wamekubali. Lakini hata kama wamekubali, for purposes of making the class sweeter, I will not just begin from the beginning like a teacher who does not know what they are doing. What I will do, I will come here and start with what we call easy ones first. Easy ones first. Easy ones first. So easy ones first, the 4 pages that I should be able to knock down very fast is what we call data visualization. Data visualization. Data visualization, this is where we'll begin from. Ladies and gentlemen, after we have collected our data, it will be very important for us to go ahead and capture. It will be very important for us to go ahead and capture this data in graphs, in pictures, because generally people outside here understand visuals, what they're able to see, vision, what they're able to see much better than write-ups. So basically, when we talk of data visualization, these are basically pictorial representation of our data. So you could have, in this case here, for example, our normal graph, which has got y-axis, x-axis. So you can decide, for example, to draw a scatter diagram in which if we draw a scatter diagram, then we shall be able to deduce the relationship between, for example, two variables. So if, for example, these scattered points are moving in a way showing a positive relationship, then we shall be able to say that these two variables are related positively, meaning that as x increases, y does what here? Increases. Are you able to see? Are you able to see my handout? Are you able to see my handout? Are you able to see my handout here? Great, thank you very much. So data visualization in Excel. Definition of data visualization. Data visualization is a process of creating graphical representations of data, in order to make it more understandable, interpretable, and actionable. It is a way of representing large amounts of complex data in a way that is easy to understand and interpret. Data visualization can be used. Data visualization can be used to identify patterns and trends in data, to make predictions, and to support decision making. It can be used to represent data in many different ways, such as charts, graphs, maps, and infographics. The goal of data visualization is to effectively communicate information and insights derived from data to various audiences, including business leaders, decision makers, and analysts. So I'm repeating again that the most important objective of data visualization is to effectively communicate information and insights derived from data to various audiences, including business leaders, decision makers, and analysts. Ladies and gentlemen, if there is any group of professionals I really look down upon on matters presentation is accountants. Accountants were not very good presenters. You will get, for example, an auditor going to read a whole audit report without any graphics. As much as my report is well structured in the OCT, as well as my report is well structured under the international standards of auditing, the ISA. Ladies and gentlemen, if I'm a good presenter, at some point, I should be able to pull some graph, pull some PowerPoint by the side, and tell this audience of mine that, you know what, why I'm qualifying this thing, why I don't agree with these directors is because of these revenues. Revenues last year, look at that graph. Revenues last year, they were 20 billion, and they're saying that this year revenues are 40 billion. There must be some creative accounting. So when you pop up a PowerPoint presentation like that, then, ladies and gentlemen, people will take you seriously because now you're using what we call data visualization. People don't like so many stories. Even pastors, nice pastors nowadays have also known how to make use of these visuals for purposes of what here? Preaching, right? So even ourselves, sometimes we come up with a data that we've been able to harvest. We must sit down and draw a graph, for example. This graph will help show the patterns. So when somebody sees those patterns, how the graph is rising, somebody will be able to say, hey, I can see my dividend is increasing very fast. Let me hold on to my shares because it means that in future, my dividends will be better. If you kept on telling these guys stories that, you know what, 2019, your dividends were 10, 2020, dividends were whatever. So they can't follow through your stories. Visualizations are very important. Okay, so we've just started the chariot. So data, the goal of data visualization is to effectively communicate information and insights. derived from data to various audiences, including business leaders, decision makers, and analysts. The use of data visualization helps to identify patterns. It is used to discern trends and even outliers that might not be apparent from looking at raw data, and it can help to identify the relationship between different variables. Data visualization in Excel involves creating charts and graphs to represent data in a way that is easy to understand and interpret. Excel provides a wide range of options for data visualization, including what kind of graphs can I draw, charts can I draw from my data in Excel. I can do column charts. These are used to compare data across different categories. They can be used to show the difference between values over time or the difference between different groups of data. Ladies and gentlemen, remember how these column charts look like. So for example, if it is sales for 2019, I'll have a column, the one that stands up like that. Then I have a sales for another year. So once we have these particular sales captured in form of what here, in form of our columns, then at the end of the day, we shall be able at the end of the day, we shall be able to do what here, somebody to make comparisons. Then we have the line charts or line graphs, which are used to show data trends over time. They can be used to show the progress of data over time to compare data across different categories. Then we have the pie chart. I hope everybody is able to see that circle, a pie chart. These are used to show the proportion of different categories of data. They can be used to show the distribution of data across different categories. We also have bar charts. These are used to compare data across different categories. They can be used to show the difference between values over time or the difference between different groups of data. Scatter charts. These are used to show the relationship between two sets of data. When you draw a scattered diagram, you would basically want to show the relationship between data. They can be used to show the correlation between two variables or the distribution of data. Pivot tables, ladies and gentlemen, are a very important aspect of data visualization. Pivot table is a powerful tool that allows you to analyze, summarize, and compare data. It helps you to view the same data in multiple ways by dragging and dropping fields to different areas. Don't worry about this. We shall be looking at this when I start doing some Excel with you. You'll be able to see the various types of what here, data visualization tools that we have in Excel. For now, don't cram anything. I just want to build a foundation for ourselves here. Great. Now, ladies and gentlemen, benefits of data visualization. These things come in your exam in multiple choice questions, part A. Very important here. Benefits of data visualization. Data visualization has many benefits, including what? Improved understanding of data. Data visualization makes it easier to understand complex data by representing it in a visual format. What people can see, diagrams that people can see. This can help users to identify patterns and trends in the data that might not be apparent from looking at the raw data. Enhanced communication. Ladies and gentlemen, we normally use this data visualization to communicate some information easily. So enhanced communication, data visualization can be used to communicate data and insights to different audiences, including business leaders, decision makers, and analysts. It can be used to communicate complex data in a way that is easy to understand and interpret, so for communication purposes. Increased insights. Data visualization can help to uncover insights that might not be apparent from looking at raw data. It can help users to identify patterns, right? To identify patterns, all right? To identify patterns, trends, and outliers in the data, and to understand the relationship between different variables. Ladies and gentlemen, when you are making use of data visualization, people will be able to understand your data more deeply, right? There's an increased insight here, very important. Improved decision making. Data visualization can be used to support decision making by providing a clear and a concise representation of data. This can help users to identify key trends and patterns and to make data-driven decisions so that the decisions we make, ladies and gentlemen, are backed up. We don't want to make decisions just haphazardly. We would want whatever decision that we make, it has to be backed up by what here our research thoughts, research processes. So when we have this information captured in form of a diagram, it will be very easy for us to even make decisions, because there are some directors who are very lazy. They don't want to go like through a whole report. But if you give them, for example, visuals, they'll be able to make decisions easily. For example, for those of you who have ever boarded onto Qatar Airways, right? Those guys have discovered that so many of their travelers can't read their menu. So what do? They bring you a menu which is computerized, which shows, for example, chicken. So when an old mzee sees chicken and they love that one, you'll even see them smiling. So it helps them to improve decision making in this case, in this particular case. So mzee will just smile a little bit and they touch, I want this cuckoo, like that. It's much better than giving a very complicated OTM menu. Identifying areas of improvement, yes. Data visualization can help to identify areas of improvement by highlighting areas where performance is lacking. This can help organizations to focus on areas that need improvement, Ladies and gentlemen, remember, when you're making use of data visualization, those graphs, you can easily command them that if performance, for example, has not reached 10, whatever, in a particular year, let that bar chart, let that column be highlighted in red. All right. So we are able to identify, ladies and gentlemen, areas of improvement very easily in data visualization, as opposed to just having what here, to just having a lot of narrations and values, which in this case you have got no tail, no head. Great. Time saving, I don't even have to read this really. Data visualization can help save time by providing a clear and a concise representation of data rather than having to go through large amounts of raw data to find insights here. Cost effective. Data visualization can help organizations to save money by providing a clear and concise representation of data rather than having to invest in expensive data analysis solutions. Better communication with non-technical people. Data visualization can help communicate complex technical data to non-technical people by providing a clear and easy to understand representation of the data. Overall, data visualization helps to make data more accessible, understandable, and actionable, which helps organizations to make decisions easily. Ladies and gentlemen, I would want to jog your memories a little bit. I know these are very, very many points, but at least a good student who is above average should be able to remember like 3 benefits of data visualization. Which 3 benefits of data visualization are you able to remember, my good students? Any 3? Why should we encourage companies to make use of data visuals, to use graphs? Why is it that if you go to EABL's annual reports today, you'll get so many graphs being used other than what narratives? Yeah, better enhanced communication from faith, time saving, because instead of you reading the entire report, I mean, if I see a graph, I'll be able to see whether these guys are making improvements or not. Better understanding, increased insights. We are able to see much more than we would have seen if we were just going through our raw report. Insights. I like the concept of insights, because insights, we are able to see deeply with this data visualization. visualization. There is also the concept of what, ladies and gentlemen, here, the one of you being able to communicate better to non-technical what here people, right? These non-technical people will be able to understand you much better. Look at, for example, the circles. Look at circles. Like I liked my manager, my director of finance at Mwasibu Circle during the COVID times. This guy came to the AGM and he was able to portray a very good graph and told people, you know what? Look at, for example, he derived like 10 years back from 09, 10, 11. Look at, for example, our earnings. Earnings have albeit slowly, but they have always been doing what you're going up. So this big decline that you are seeing in this particular year, 2019, right, is not out of our mystic. This is the effect of Corona. That guy was spared. He was not voted out. And I'm so sure that graph really helped, especially the non-technical people, to understand, hey, if these guys have been really improving every other time, I mean, this is an outlier. This particular year has been affected adversely simply because of what your COVID, right? Also, the concept of bringing out areas of improvement comes very well when you're using the data visuals. Ladies and gentlemen, outside here, like where I work, we rely a lot on what we call dashboards. So using dashboards, which basically come to us in form of graphs, I will be able to know how sales in a particular region, for example, Mount Kenya region, if I'm the manager of EABL, I'll be able to see Mount Kenya region, where in this case here, our Honorable Deputy President, Rigathi Gachagua, keeps on saying that people are drinking so you'll be able to see, ladies and gentlemen, like if it is Tusker here, how straight away using these bar charts, using the column charts, I'll be able to see on my dashboard how Meru is performing, how Nyeri is performing, even comparing, making those comparisons between regions, right? You can imagine, like, if I was depending on raw data with narratives that yesterday we sold 10 million bottles of whatever, this is the day we sold in Meru, in Kisii, in wherever, it would have been very cumbersome. Why don't I just capture this, everything on dashboards, everything on visual displays, and communicate this much better? It will save time for managers. So now managers can also get excess time, which now they can use for other management functions. So there is a concept of cost savings, the concept of time savings, right? Now, ladies and gentlemen, please listen, and I'm so happy because you've been able to participate in this all important exercise. Now, ladies and gentlemen, we come back here. Great. Types of visualization. We'll have visualizations that are useful in terms of comparison, where we look at the compositions and, of course, the relation. Like when I hear of relationships, I always remember the scatter diagrams. Positively related variables, negatively related variables, the ones in this case here without any relationship. There are several types of data visualization, each with its own purpose and strengths. Some of the common types include comparison visualizations are used to compare data across different categories, such as comparing the performance of different products or the sales of different departments. This can include charts such as bar charts, column charts, and line what here charts, where you'll have a line of Tusker. You will have a line of Tusker of being sold in a particular region over time. That one line, another line for, in this case here, the one that has got Michael Power. Michael Power is Guinness. And then we have another line, ladies and gentlemen, for what here? For sales of this brand, which makes you stand tall when you drink it. Is there somebody who knows that brand which normally enhances the height of children? Is there somebody who knows that brand? You know, this EABL is a bad company. They advertise in a way that will woo, not adults like us, but our children. You guys, it's like all of you are going to heaven because you don't know the slogans that EABL uses. It's like you don't know the slogans that EABL uses. Konyagi, no. Festus Konyagi, no. Konyagi does not make you stand tall. No. Guinness is the one that has got micro power. Standing tall is Tasker. Do your research. Do your research. Do your research. And it's important that you get to know these things so you can advise your kids. Tell your kids that when you see these adverts, all of them are geared towards cheating the young people. You know, you and I, at our age, we know that if you are born short, you will remain what year? Short. At our age now. But you see somebody who is a pygmy at secondary school, when they are finishing the secondary school, and then they come home, the first thing they see on putting their boxes down is an advert telling them to how they can stand, in this case here, how they can how they can stand tall. So it's important for you to know these things. Kanisa sana. No. Kanisa, lakini watoto wako wanaweza kunywa pombe rahisi sana. Thanks my home, I can see you live. Now, so comparisons, where you're comparing metrics of different products, metrics of different years. For example, I want to look at EPS of 2020, EPS of 2021. When I'm comparing, then visualizations here like these bar charts come in handy. Then we have what we call composition. Composition. So under composition, ladies and gentlemen, normally to see how various components are fitting into some whole. Various components. Like, for example, give me the total sales of Coca-Cola in a year. For example, 20 billion US dollars. And then I would want to know, out of these 20 billion US dollars, what do we have? Amount do we have which was contributed by Coke? So a pie chart. A pie chart is the one that comes very well to show us the constituent components. All right. So we are trying to, that pie chart. You guys, are you able to remember how a pie chart looks like? Are you able to remember how a pie chart looks like? Are you able to remember how a pie chart looks like? This is some of the people here have forgotten a pie chart. Some people here have forgotten how a pie chart looks like. How a pie chart looks like. Some people here have forgotten how a pie chart looks like. How a pie chart looks like. This is how pie charts look like. Disappeared. Yes. Great. Great. No. It's opening slowly. What may have happened here now? Let me just check a moment. We're going to see what happened. Yes, these are the pie charts, various pie charts. Various pie charts. Various pie charts. So if, for example, this is a pie chart of sales, I'll be able to see this particular component. I mean, what is the percentage? How much in terms of sales? etc, etc. So a pie like a donut pie chart. Very important. It demonstrates numbers of the studies per the composition of the whole. Thank you so much. Ladies and gentlemen, then that takes me to something else which is very important here. So composition visualizations are used to show the proportion of different categories of data. They can be used to show the distribution of data across different categories. These include the charts such as pie charts. We have stacked bar charts, and stacked column charts, Is there anybody who is able to remember how a stacked column chart looks like? Is there anybody who is able to remember how a stacked column, let me get one here, pull one here for you. Great. So this is how a stacked column chart looks like. Very good for also showing composite. So you can see like this is one that is stacked with the blue and the yellow colors. So we're able, for example, to tell in a particular region, how did UDA perform? The blue people, Azimio, how do they perform? So you can see the composition is stacked, where you have one column being done what you subdivided. And if you can be presenting them in 3 dimensions, 3D. 3D comes out very well, very nicely. We shall be looking at this when we go to Excel. But for now, what I want you to understand is that, ladies and gentlemen, when we talk over compositions, we shall be looking at pie chart to show the various components. We shall be looking at the stacked, where you have one column like this subdivided, showing Coca-Cola, showing Fanta, etc. like that. Composition. Then we have what we call relationships. So relationships here, we are looking at the trends. Basically, relationships, we are looking at what we call the scatter diagrams, right? Scatter diagrams, right? So relationships here, relationship visualizations are used to show the relationship between 2 sets of data. They can be used to show the correlation between 2 variables or the distribution of data. This can include charts such as scatter plots. Let me show you what scatter plots are. Great. Let me just look for a scatter plot or scatter diagram. Positive relationship. Positive relationship like that. Great. So, ladies and gentlemen, here we are. So if you look at my graphs here closely, you'll be able to, if you remember what you used to do in high school, we're drawing this kind of a scatter diagram, scatter the points, and then what we are doing is to put a line of best fit. So when we put this line of best fit and we see that it is moving to this direction like that, this is what is used to call the positive direction, which shows that like here, number of brains eaten, number of brains eaten, how much of a zombie you are. Those are very bad variables. Very bad variables. But now I can see from here, ladies and gentlemen, that in this case here, the 2 graphs are what the 2 variables are positively related. We also have a negative relationship. We have a time situation where we are not able to have it. Like now, these are very badly scattered. They're very badly scattered. Even if I can still fit in some line there, but these are really far, far away. I can even deduce that there is no what here relationship really as such, unless I want to force this. Unless I want to force this. So, ladies and gentlemen, what have we said about data visualization? What have we said about data visualization? When we talk of types of visualization, comparison, composition, and relationships, what type of graphs do we have under comparison? What types of graphs do we have under comparison? Is there somebody who can remember the types of graphs that we can do for comparison purposes? Don't read my, for comparison purposes. I know for comparison, when I want to compare between which and which is taller than the other, I will use column charts basically there. Column charts basically there. Thank you so much. Column charts. How about composition? How about composition? How about composition without looking at my write-ups? What type of graphs will you use? Pie chart. Thank you very much, Ngozi Robert. Pie chart. George Elisha, thank you very much. Pie chart or a stacked column chart. Stacked. And then lastly, how about the types of graphs that you will use for purposes of relationship showing? Relationship showing, scatter chart. Leave alone those bubbles for you. Remember that will be scatter chart. Oh, Ndego is even able to remember heat maps. Great. Thank you so much. Now, ladies and gentlemen, I will be able, with your permission, I will be able to move forward. With your permission, I'll be able to move forward. Distribution and visualization are used to show the distribution of data, such as showing the frequency of different values in a data set. These can include charts such as histograms, box plots, and the density plots. Ladies and gentlemen, remember when we talk of distributions, what comes to my mind? Ni kale kahesabu, kale ka diagram ka ugali ya Mluya.
You see, ile kitu ya ugali ya Mluya, what we call a normal curve, is a density function. It is a distribution function. It is a distribution function. How are points being? Of course, most of the points will be clustered around where the mean, around the mean. If I show you something here, ladies and gentlemen, about this normal. Let me just look for the normal distribution. You'll be able to see the density. Great. I hope we shall be able to get it very fast. I just want to show you, ladies and gentlemen, how this graph looks like. Yes, it is here, although in the form of a video. So, ladies and gentlemen, when we talk about how points have been distributed, even how you guys get your marks, you see, CASNEB would want you guys to have your marks clustered around the mean. Around the mean is where we have a lot of distribution. A lot of you will be around here, right? So that those ones who fail should be fewer. And of course, the ones who pass highly should be fewer. Who pass with like distinction should be fewer. But pass, if the pass is at the middle here, then we should be able to get most of you doing what here. The most important thing that I would want you to appreciate, ladies and gentlemen, is something very small here. Is something very small here. When we talk of distribution visualization, distribution visualizations are used to show the distribution of data, such as showing the frequency of different values in a data set. This includes charts such as histograms, box plots, and density plots. Geospatial, here we are looking at the geographical space. So we are coming up with data and then we represent it in a geospatial way, geographically. Meru, we have Nakuru, we have Kajiado. So geospatial visualization are used to show data on a map. These can include showing location-based data such as sales by region, or data about geographical features such as population density. These can include maps, choroplates, and the cartograms. These are kind of language I would want you guys to Google and to get this information. Once I send you this document, I would want to get, because I'm sending it in Word format, I would want to get students who are also making their own notes like below here. What is a choropleth? What's a cartogram? Through Googling. Hierarchy visualizations are used to show the hierarchy structures of data, such as showing the parent-child relationship between different categories. This can include charts such as tree maps, sunburst, and cycle parking. Each type of visualization has its own strengths and weaknesses, and the choice of visualization will depend on the specific needs of the organization and type of data that needs to be visualized. You see, like now, how this question was being asked. Which of the following correctly defines composition as a data visualization technique? Last semester's December 2022, question 18, BDA. Which of the following correctly defines composition as a data visualization technique? The method of graphical representation of data and information. The method that shows the differences or similarities between values with and without axes. The method of presenting a part to whole relationship of data and information. The method that shows the relationships and the connections between the data and information. So could you kindly, ladies and gentlemen, please guess which answer there is correct? Not guess, but of course from, I mean, I've really shouted here. I would want to believe that somebody will be able to get this. I would want to believe that somebody should be able to get this very easily. Somebody should be able to get this very easily. Somebody should be able to get this very easily. Very easily. And of course, the one who gets first should be able to get, with a good explanation, however, with a good explanation, if you explain very well, then you should be able to get a present. You should be able to get a present. You should be able to get a present. So they're saying a representative of data via graphs, pictures for consonant. Remember here, they are asking about composition. They are not asking you about what is a data visualization. They are very specific composition, which you guys told me that composition, Mwalimu, use a pie chart. Use a pie chart. Use a pie chart. I'm not mentioning anything for now. Allow Mwalimu to continue a little bit. I'll come back to the questions at the end of the chapter. So 2.4 for qualities of good data visualization. A good data visualization should have several key qualities, including clarity. A good graph should be clear and easy to understand. It should present data in a way that is visually appealing and easy to interpret. Relevance. A good data visualization should be relevant to the data being represented and the audience that is being presented to. It should be used to communicate information and insights that are useful and actionable. Now, ladies and gentlemen, just imagine that we are making a presentation to some audience, which is an audience of members of Mwasibu Sacco. And then you go there very seriously, you as a director of finance. And then when you start making good presentations there, you pull a visualization. Perhaps you want to make them laugh. But unfortunately, it fell. It automatically, in this case here, falls on deaf ears. Nobody even understands your joke. So here you are trying to show them, for example, the various species of fish that we have. So you have a graph. This is Kamongo. This is, those guys are not there to listen to such kind of nonsensical issues. The most important, relevant visualization they want to hear is that visualization which will tell them how much in form of dividend will they get. So regardless of how good your visualization, your graph is, your pictorial presentation is, if it does not relate well with the audience, then that thing is as useless as nothing. So number one quality or number two quality of good visualizations, they must be relevant. They must be relevant. They must be relevant. I'll be asking a question regarding this in a few minutes. Ladies and gentlemen, accuracy, of course, we don't want to present anything that is what here inaccurate. They must be simple. Remember, ladies and gentlemen, that at the end of the day, some of the people that you're going to present this information to are who we are. These are directors. These are directors. These are directors. Some directors got into some of these positions not because of their academia. They got into these positions simply because they had money, they have enough shares. Just imagine like the late Njenga Karume, may his soul rest in peace. This guy never saw anybody's door to a high school. But you see, he was sitting in very many boards. So if you are to help these people to make decisions, then such people, to make decisions, then ensure that your visuals are simple to understand. Simplify them. Kama ni menu, wewe pelekee menu ambayo iko touch screen, unaonyesha hii ni kuku, hii ni samaki, anaguza. visualizations which are part of the pictograms, they must be simple. That's a very important characteristic. It's a very important quality. Very important quality. Great. Then we have scalability. A good data visualization should be able to handle large amounts of data and be scalable to different devices and OTA screens. Ladies and gentlemen, this of course goes without saying that data visualization, basically, they should be a computer in a computer device. You can increase their size, right? And especially if you have done them using Power BI, or if you have done them using the pivot table, when, for example, you introduce like a new variable like bread, automatically, if it's a good visualization, then we expect scalability. We expect this graph to accept new, scaling means you can change. You can change both the content, you can change the size. Scalability is a very important attribute of any good visualization. Now, this concept of scalability is so important, especially for dashboards. You see, like I was trying to explain to you, this thing about what here, this thing about sales of beer in, for example, where Nancy McKenna comes from. Nancy McKenna, good to see you around. This time around when you passed, you never told me you have passed. We shall overcome. Happy New Year. We shall overcome. So where Nancy comes from, if, for example, some year we get sales of beer has gone down, I don't need anybody to come and draw this graph afresh. This graph should be connected to the original data such that when the original data changes, then we expect this particular graph, this particular column to also go down if it was a decrease or to go up. So we should be able to see those dashboards on a real life situation, moving up and down, moving up and down, moving up and down. Scalability, very important. Then we have, ladies and gentlemen, here, the concept of what here, flexibility. A good data visualization should be flexible and allow users here to interact with the data and explore it in different ways. Quite similar to scalability. It should provide options for users to filter, sort, and explore the data in more detail. Consistency, even in color format. A good data visualization should be consistent in its use of colors, scales, and other design elements. It should also be consistent with other visualizations used in the organization. Corporate color, context. A good data visualization should provide context and background information that helps to understand the data. It should be accompanied by explanations, annotations, and the titles that provide additional information about the data. Should provide context, background information that helps to understand the data. It should be accompanied by explanations, annotations, and the titles that provide additional information about the data, about the data, about the data, about the data. Great. Great, great, great. So, ladies and gentlemen, let's go back to the other sections. I only skipped on a section that was quite easy for all of us to follow. Everything here is really easy. Everything here is really easy. Everything here is very easy. Great. And today we have to finish this. Today we have to finish this. You told me to start from page number 1. Introduction to data analytics. And I'll read very fast, really. But maybe I should give you like 5 minutes to stretch a little bit. What do you think? Can I give you like 5 minutes to stretch a little bit? It's important to stretch out when you come back. We should really be able to dance together in this, the greatest subject of them all. I give you 5 minutes. Yes, that's very important. So shall I come back at 9:01? 9:01. So let's continue, and we're going to make this class very interesting. The remaining part is very interesting. So, and we shall start right away from the very beginning here.
So chapter 2. Data analytics is the process of examining, learning. When we talk of analyzing data, what is the process? What is this data analytics? It is the process of examining, cleaning, transforming and modeling data to extract useful information, draw conclusions, and support decision making. Ladies and gentlemen, remember, at the end of the day, companies don't just make decisions haphazardly. Companies would want whatever decision options they pick to be supported with facts. So to get these facts, then if, for example, you're looking at a company like Coca-Cola. So Coca-Cola, one of the things that it produces inside there are bottles. Bottles. So, but you see, making of bottles, manufacturing of bottles is never a primary duty of Coca-Cola. Coca-Cola is all about the drinks. That is their first primary duty. So all these secondary products they are making, including services, secondary services they are making use of, ladies and gentlemen, the world about these non-core services, products, the world over is looking at outsourcing. If you look at, for example, most banks nowadays, what do? You rarely get a bank that has employed a guard. What they do, they bring services over a security firm which is able to provide guard. So they outsource. You can never get a bank employing a T-girl. Nowadays, banks, because they are known for banking services, any secondary function or activity which really doesn't support their very primary core of existence, they will always do what you think of outsourcing. So the same case with this Coke. Production of bottles is never their core thing. So every time they would want to make a decision, do we continue producing these bottles inside here? Do we continue? No, we haven't completed anything. We have actually started from the beginning and then we move like that. Oh, I know what you guys are talking about. We have not done chapter 1. We have not done chapter 1. Let's just agree. Whatever you have done in chapter 1, Mwalimu will repeat everything. You know, it's like you're starting from scratch. Because of how sensitive this paper is, it's a sensitive paper. You realize why I'm telling you it's a sensitive paper, right? Even Mwalimu now has been forced to prepare for this paper from scratch. Great. So thank you very much. Let's continue here. The problem with Zoom, whenever questions come in between, they disturb a little bit, but we shall overcome. It's part of learning. But I can also be organized with them and say, for example, I'll be answering like after 20 minutes, we shall overcome. So data analytics is the process of examining, cleaning, transforming, and modeling data to extract useful information, draw conclusions, and support decision making. It encompasses a wide range of techniques and tools, including descriptive statistics, data visualization, and machine learning. Data analytics can be applied to various fields such as business, finance, healthcare, and sports, to name but a few. The goal of data analytics is to turn data into actionable insights that can help organizations make better decisions, improve their operations, and gain a competitive edge. Ladies and gentlemen, data is king. Any company that knows how to make use of its data will always be ahead of the rest in terms of competition. The CRISP data mining model, this CRISP is very important. It came in last semester's exam. It is even there in the pilot paper. It will also come in your exam. Cross-industry, cross-industry standard process for data mining framework for data analytics. The CRISP data mining cross-industry standard process for data mining is a widely used framework for data mining for data analytics projects. It provides a structured approach to solving data-related problems and helps ensure that the project stays focused and on track. The CRISP data mining framework consists of 6 phases, which I taught you in the last class.
the 6 phases, and I'm going to summarize them here very fast. Number 1, we have business understanding. This phase involves understanding the problem or opportunity that the project is addressing and defining the goals and objectives of the project. This phase involves understanding the problem or opportunity that the project is addressing and defining the goals and objectives of the, ladies and gentlemen, whenever you want to start mining data. For example, if it is this IEBC data that you want me to analyze for you, I would first of all want to understand the business. If I don't understand the nature of business that my client is doing, then I'm not going to mine data that will be helpful. For example, if it's IBC, I know some of the data that will be helpful will be the data regarding who the voters who have, for example, died, so that we strike them off the voters register. So the first thing that I need to do here is to understand what data, to understand the business first. From there, we have data understanding. In this phase, the data is collected and explored to better understand its characteristics and the potential issues. We have number 3, data preparation. This phase involves cleaning, transforming, and prepping the data for analysis. So basically, you are preparing the data so that you can analyze it. You can start analyzing it. And how do you prepare this data? Of course, there are those outliers. So perhaps when this IBC register was being factored in, they took in a date of a certain mzee and said that this mzee was born in 1880. You see, when I calculate the age of this mzee, I'll be able to see straight away that this is an outlier. That is bad, misleading information, which was copied erroneously. So it is either I try as much as possible to get the ID card of this mzee, or I say this is an outlier and strike it. I must clean. We shall be able to see the concept of transforming, preparing the data for analysis. That's number 3. Number 4, now we have the modeling bit of it. The data is then modeled using statistical or machine learning techniques. So when we have collected this data, for example, we have like what came last semester, regression analysis. Now we need to go and put this data in a regression model so that we process it. Number 5, evaluation. The models are evaluated to determine which one best meets the objectives defined in the business understanding phase. Ladies and gentlemen, under evaluation, of course, there is no, if it's regression analysis, you're going to do various simulations. Assume, for example, this is Y versus X. Run the model. Go and assume that now we have got 2 variables, Y, X1, X2. Run the model. And then now you should be able to evaluate these models. Which one, for example, has the highest coefficient of correlation? Which one has the highest coefficient of determination? So of course, you shall not develop just one model. In short, you shall develop many models, like 2 or 3, and then you evaluate them. The one, of course, that pleases you, that is able to meet your expectations, is the one that you recommend for deployment. And the final model is deployed, and the results are communicated to stakeholders. Ladies and gentlemen, I know we are quite late, but I would want my students here to understand. I would want to see whether there is anybody who has been able to understand these 6 steps by writing them down very fast using their pens, and if possible, they share that picture on WhatsApp. The steps of the crisp steps, we call them the crisp steps. Is there anybody who is able to write them down very fast? Write them down very fast. Or even here, if you are able to chat to them, the way they follow each other. I know there is business understanding. I know there is data understanding. Number 1, business understanding. Number 2, data understanding. That one I will never miss. That one I will never miss. That one I'll never miss. Yes, admin, I will do that, yes. Business understanding, thank you very much, Dorothy. Business understanding. Rhoda, business understanding. So if I were able to say 1, business understanding, and then I say 2, data understanding, so you're going to move fast. So 1, business understanding. 2, data understanding. 3, yes, I like what Terry is doing there. Try to use even shortcuts. 3, modeling. Are you sure? Are you sure you start modeling immediately after? There is data preparation. Thank you very much. There is data preparation. Yes.
Esther says the Great. I can see somebody who has all of them. Good to see Eileen. Great. Modeling, evaluation, 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 and then 6, lastly, deployment. So that is so important to me. That is so important to me. Now, ladies and gentlemen, from there we go to the CRISP-DM framework is iterative, meaning that the phases are not strictly linear and may be revisited multiple times during the project. Iterative iterations means what here? A number of times, number of steps. You don't have to say that you're going to go for evaluation just once. You must keep on going back to them just to confirm that everything, there are loops in, if you remember, there is even a diagram that I showed you here, which shows that this thing is like a wheel, which is supposed to iterate, which is supposed to be moving. Now, we have this question that was tested last semester, and so few of you were able to get it right. The data concepts, 3 of them. So this data, as we try to understand this, we shall have what we call the conceptual stage. We shall have the logical stage. We shall have the physical data models. Ladies and gentlemen, when, for example, you come to me to do a house for you, if you want me to do a house for you, assuming I was an architect, I'm not an architect. So then what I'll do, I'll sit down with my client, and then we will start by putting down our ideas into a concept. So assuming this is a lady who wants quite a huge house. So they'll come and tell me, you know what, I would want this house to have like this number of bedrooms. You know, it's in our mind. So first of all, as an architect, I'll just keep quiet for about an hour just to listen to the client. That I would want my master bedroom to be on the first floor, to have a great balcony that is swinging, so that when I'm reading my newspaper outside there, I should be swinging a little bit as I also bask there. Soft life, good life. And then she'll tell you what, I would want that to be the only bedroom up there. I am listening. Now from there, of course, I'll even try to now look at the logics by putting down whatever concept now I have in my head as per her explanation. So I'll put down. Then I'll now start questioning the logic here. I mean, when you tell me that you don't want any other bedroom up there, in African setup, logically, is it good for you to have a master bedroom up and then your children sleep down? Somebody talk to me. Is it logical? Is it logical that we have the master bedroom, the parents, both of them are sleeping up there, and then the kids are sleeping down? And remember, down is where we're going to have guests. So would you want your little girl, little boy to mix with guests? No. So we'll disagree with that. We'll disagree on that. And again, now remember, even when we are sleeping up there, nowadays we have very cheeky children. This child may even decide to go out at night. And then in the morning, they are cooking tea for you as if they have not done nothing. I know that may not make a lot of sense, because you guys will tell me that these kids are mature enough, they can take. It's an African. It's not logical. Again, ladies and gentlemen, remember one person told us, I can't remember who it was, that when you are designing your bedrooms, the master bedroom that is up there, you must ensure that the guest room that you have should be exactly the same as the master bedroom up. So it's like you have 2 master bedrooms, one for you when you are a young parent, and then we have, in this case here, the guests down. Do you know why this guest room must be exactly identical to the master room up? It's because the moment you reach 60, you will not be having enough energy to go up the stairs. Yes. Well, Rui, I can see you understand this thing. You understand this thing. So you will become a guest in that house one day. You'll become a guest in that house one day. You'll become a guest in that house one day. There are things you're supposed to know in terms of really designing of a house. For example, your master bedroom, the balcony should always look at which side? The sunrise. Sunrise.
Because when you are at about 50s, you don't want to go down. You'd want, in this case, to bask the morning light, etc. Those are things you're supposed to be. But now remember how this thing started. It started by conceptualizing concept. And then now we have what here? Somebody, we have logics down here. From there now, what do? We go the physical way. And the physical way, like nowadays, what the current architects will do, they'll go and draw this in the ArchiCAD. They draw in this architectural card. It's quite a powerful software. They put in 3D, and then what they'll do, watatafuta maboxes, wanakutengenezea kamfano kayo. Before I end the physical, before now physical, the construction stage, watakupeleka through conceptual, logical, physical, of course, through dummies. And then now they hit the road with what here? The real thing. The same case with the data modeling. When it comes to data modeling, conceptual, logical, and physical data models are different ways of representing data and relationships between them. Listen here, conceptual data model. A high level representation of the data and the relationships between them, a high level. It's typically used to communicate the overall design of the data model to stakeholders who may not be familiar with the technical details. It's a concept. A conceptual data model is independent of any specific technology or data-based management system. So remember here, we have not even started doing any modeling. We are still simply thinking out loudly. So as we are thinking, we don't even know which specific technology we shall be using. We don't even know whether we're going to store these in a database management or which one. It's independent. From there, number two, we have the logical data model, a more detailed representation of the data and the relationships than a conceptual model. It describes the data in terms of the data requirements of the organization and is as well independent of any specific technology or database management system. It's still the logics, remember. From there, now we go to three, physical data model, a representation of the data now and the relationships that is specific to a particular, now here we have started the design, is specific to a particular database. If it's MySQL, it's specific to a particular database management system or technology. It includes details such as data types, indices, and what constraints do we have. A conceptual data model is the highest level of, it's like an abstract in your thesis. Logical data model is more detailed and specific, and the physical data model is detailed representation of the data in a specific technology or a database management system. That question was asked last semester. Most of you who are doing this exam did not see it. No worry. Let's look ahead. Let's look ahead. Stages in data life cycle. Data life cycle. Data life cycle. Ladies and gentlemen, remember, we have what we call the life cycle. We have what we call the life cycle. And this, I have to look for it, the life cycle. I have to look for this. I have to look for this so I can show you. Great. Great. So remember the normal life cycle that we people go through, the normal life cycle that we people go through as human beings. So as human beings, even before introduction, there is what we call research and development. So research and development will take some time here. And then now you are born, what we call introduction. After you are born, not unless you're another one, after you've been given a few spoons of Cerelac, none, and your mom's breast milk, we expect you to do what? You have to grow. Again, if you are to grow forever, you'll become a giant. So after some time, we expect you to mature. Maturity, again, you can't just remain upstanding. You'll start having your back bending a little bit. And then you'll be able to decline like that, until you reach a stage that we call death and what year withdraw. So there must be research and development. Don't ask me what happens at this research and development for a person. Don't ask me. This is supposed to be fairly obvious. Or if you would want to know, ask your father and mother. And then now we have being born. After being born, you grow, you mature, and then you do what here? Decline, and then there is a death, and what here? Death and withdrawal. Very important product life cycle. We also have what now we call the data life cycle. So for data life cycle, what do we have there? For data life cycle, what do we have there for data life cycle? So for data life cycle, stages in data life cycle, we must identify the data sources, modeling the requirements, basically understanding what is required of us. Then you obtain the data, you record the data, using data for decision making. And then at the end of the day, of course, data cannot be left in a database permanently. If it has been useful and we've been able to exhaust its usefulness, we must remove. There must be death of the data. There must be death of the data. So the data life cycle can be broken down into several stages, including identifying data sources, right? This is what we call the research and the basically development. You're doing research. This stage involves identifying the various sources of data that are available and determining which ones will be more relevant and useful for the company's needs. And then number two, it is understanding, actually don't use the word modeling, understanding the data requirements. This stage involves understanding the organizational data needs and developing a data model that will support the company's goals and what year objectives. You must understand the requirements. After you've understood the data requirements, then number three, you go to the field and obtain data. This stage involves acquiring the data from the identified sources, which may include data collection, data acquisition, data integration, and the data validation. Obtaining data. Number four, we have recording data. This stage involves storing the data in a way that can easily be accessed and used for analysis. This may include data warehousing, data lakes, and the data mart. So you shall be able to see what these things stand for. For now, know that this data has to be recorded. It has to be stored in a data warehouse. Using now data for decision making business decisions. For making the business decisions. This stage involves using the data to make informed decisions and improve business operations. These may include data analysis, data visualization, and machine learning. And then lastly, number six, we have removing data. So ladies and gentlemen, please tell me, among these 6 steps of data life cycle, which steps are you able to remember in that order? Which steps are you able to remember in that order? Are you able to remember? Are you able to remember them? Which steps? No, you can't start with modeling. You can't start with the modeling. Identifying the data sources. I love that. Number 1, please write 1. And then you write 2. Identify the data sources. If I were you, I would repeat that. Identify data sources. Understanding data requirements. I'll pick that as number 2. Understanding data requirements. So now we are in number 3. Now we're in number 3. After I understand data requirements, number 3, we go to the field, obtain data. Thank you so much. Now we are in number 4. Number 4, we record the data. Number 4, we record the data. We record the data. Number 5. Number 5, use data to make decisions. Use data to make decisions. Number six, lastly, removing the data. You remove the data. Thank you so much. Thank you so much. We are doing so nice. We are going on so well. Now, ladies and gentlemen, we move on to the next step. Big data and the data analytics. We have done this in the last class, but we have agreed we are reading this pretty fast with yourselves here. Big data refers to extremely large and complex data sets that cannot be easily processed and analyzed. Big, complex data sets that cannot be easily processed and analyzed using traditional data processing techniques. These data sets are often characterized by their high volume, velocity, and variety. The volume is big. They would need very fast processing systems because, this involves things which are changing very fast: velocity, speed, variety, various sources. They can come from a variety of sources such as social media, Internet of Things devices, and the business transactions. Data analytics is the process of examining, cleaning, transforming, and modeling data to extract useful information, draw conclusions, and support decision making. In the context of big data, data analytics involves using advanced techniques and tools to process and analyze large and complex data sets. They may include distributed computing technologies such as Hadoop, NoSQL databases, and specialized data analysis software. You shall be able to understand this as you get along. This time around, we are not sparing any stone. All stones must be turned. The most important thing, ladies and gentlemen, for you here is the definition of data analytics, the process of doing what here: examining, cleaning, transforming, and modeling data to extract useful information, draw conclusions, and support decision making. Big data analytics can be used in many industries and domains, such as the healthcare, finance, retail, and transportation. It can help organizations gain insights from their data, such as discovering patterns and trends, identifying customer behavior, and detecting fraud. One of the challenges of big data analytics is dealing with volume, velocity, and a variety of data. This can include dealing with data storage and the processing, dealing with data quality, and dealing with data governance. Additionally, big data analytics often requires specialized skills and resources such as data scientists and engineers. I'm so sure you guys have forgotten about the big, but you guys are very clever. You cannot forget about the 5 V's of big data. The 5 V's of big data refers to 5 characteristics that define big data. So characteristics of big data: volume must be big, velocity, variety, veracity, and value. So I'll read through this very fast. Volume refers to the amount of data that is generated and collected. Big data often deals with data sets that are too large to be stored and processed using traditional methods. You need database systems like MySQL to understand big data because of the volume. Velocity refers to the speed. Velocity is speed at which data is generated and collected. Big data often deals with real-time or near real-time data streams that must be analyzed in a timely manner. Speed is of essence. Variety refers to the different types of data that are generated and collected. Big data often deals with structured data such as relational databases, as well as unstructured, such as text, images, and you'll understand what we mean by structured and unstructured in our next lesson, which will be tomorrow. Veracity is about faithfulness of the data. It's about faithful representation. It's about trustworthiness. It's about accuracy. Veracity refers to the accuracy and trustworthiness of the data. Big data often deals with noisy and incomplete data, which can make it difficult to extract insights. And that is why we clean up this data to ensure that it's accurate, to ensure that it is of high veracity. Value refers to the potential insight that can be gained from the data. Big data analytics is often used to uncover hidden patterns, trends, and relationships in the data that can lead to new business insights and opportunities. These 5 V's of big data are often used to describe and understand the characteristics of big data and how they differ from traditional data. Understanding these characteristics can help organizations identify the right technologies and methods for storing, processing, and analyzing big data. Types of data analytics we have, and we described this really, but we must keep on repeating. Descriptive analytics, prescriptive analytics, and prediction. There are several types of data analytics, including descriptive, prescriptive, and predictive. Descriptive is what we do in statistics. From the history, we are able to calculate the mean mode. Descriptive analytics deals with summarizing and describing the past. It involves analyzing historical data to understand what has happened and identifying patterns and trends. It is used to answer questions like what has happened and how has it happened. Predictive now is about the future. Predictive analytics deals with forecasting the future. It involves using statistical and machine learning techniques to analyze historical data and make predictions about future events. It's used to identify questions like what will happen and how likely is it to happen. When you look at 3, prescriptive analytics, we are told prescriptive analytics goes beyond predicting. Now, you know, just like how you go to a doctor, the doctor says what? You have an allergy. And then they are able to predict, right? And then, of course, if it's prescriptive, they must provide a solution that, you know, for this allergy, this drug, this drug, this drug. But for now, we are prescribing. So prescription, there must be a solution that is being recommended to you. Prescriptive analytics goes beyond predicting the future and it gives recommendations on what actions to take. I liked one question that this examiner brought from last semester's exam. This question from last semester's exam, it was quite a very interesting question. This one here, question 7 years. Ms. Daremongare is the chief executive officer, chief finance officer of Modern Company Limited. She's using data analytics in estimating the future. So if it's estimating the future, we can only talk of either predictive or prescriptive. Let's listen here. It is estimating future risks that the company is facing and also cash budgeting with scenario analysis. By carrying out risk management and cash budgeting, she is applying A, predictive analytics for risk management and cash budgeting. B, predictive analytics for risk management and prescriptive analytics for cash budgeting. C, predictive analytics for cash budgeting and predictive analytics for risk management. D, prescriptive analytics for risk management and the cash budgeting. So when you try to look at this question, does it even make sense really? Does it even make sense really? What do you make out of it? What do you make out of this question really? The answer that is there is wrong. How would have you answered this question? How would you have answered this question? Remember, I've already sent you the solution to last semester's exam. Already you have the solution. Already you have the solution. Already you have the solution. Great. So I'm giving you 1 minute to think through. You tell me what you think. Thank you so much. Thank you so much. Thank you so much. Listen and listen to me. Listen and listen to me very well. Listen and listen to me very well. You see, ladies and gentlemen, when you guys are producing budgets, you are of course predicting the future budget. I would want to do this, but you see, you as a CFO, you as a CEO, for budget, you are prescribing, you are giving recommendations there. You are giving recommendations. You are giving recommendations. You're saying that come next year, my training budget will be worth 10 million. I'm predicting fine, but at the same time giving what here? Recommendations there. I'm even putting figures there. But when I'm trying to do like a SWOT analysis to understand my risks, I'm mapping my risks. When I'm mapping my risks like this, you see what will happen. Okay, I should be able to send both. I should be able to send both. I should be able to send both. What is happening here, when I'm using this particular model, SWOT or whichever, to map out my risks, right? Right? Those are basically predictions. I'm not like 100% sure that even they will happen, right? I'm simply trying to pen down what may go wrong. This semester, I may not get this number of students. This semester, I may not do this. And so in this case here, I'm simply trying to look at, for example, the economy. It could be recessionary. I'm trying to look at but as we continue, we're going to appreciate this. But the most important thing you're supposed to know, ladies and gentlemen, here is that, please listen and look at the answer. I've already attached the answers here. It's supposed to be predictive analytics for risk management and the prescriptive analytics for cash budgeting. For cash budgeting. That is the correct answer. Listen and listen to me very well here. Now B, predictive analytics for risk management and the prescriptive analytics for cash budgeting. Predictive analysis is the use of data, statistical algorithms, and machine learning techniques to identify the likelihood of future outcomes based on historical data. In this case, Ms. Dare Mongare is using data analytics to identify future risks that the company is facing by analyzing historical data patterns. Prescriptive analytics is the use of advanced analytics methods to optimize decision making. You are making now decisions. When you're coming up with this budget, you're making decisions and suggest actions. In this case, Ms. Dare Mongare is using scenario analysis for cash budgeting to create different scenarios for company's future cash flow and suggest actions to optimize the company's cash management decisions. I continue down here. It is worth to mention that predictive analytics and the prescriptive analytics are different and used for different purposes. Predictive analytics focuses on understanding the past and the current status to predict future events, while prescriptive analytics focuses on using insights from data and models to optimize decision making and actions. Quite a tough one, but I'm so sure as we progress, we shall become what we are, great in this thing as we